Good afternoon, students. Welcome to the Unit 2. Welcome to Unit 2 of RAC. So, in the last few classes, we have discussed about the basic introduction of refrigeration and the ideal refrigeration air cycles, that is, reverse Carnot cycle and Bell-Coleman or Brighton cycle. In this class, today in this class, we are discussing the Unit 2, where we are having some other refrigeration systems and also some of the PH and TS to no. So the second unit, we have the vapor compression refrigeration system, right? We have the vapor compression refrigeration system. So let's go into the class. Yes. So in this unit 2, we are having the few topics to be discussed. That is, what is vapor compression refrigeration system? What is vapor compression refrigeration system? The working and principles of VCR and the essential components of the plant. Next, simple vapor refrigeration cycle. Simple vapor refrigeration cycle, the coefficient of performance, a representation of cycle on TS and pH charts. Next, the effects of subcooling and superheating process of simple vapor refrigeration cycle. Next, cycle analysis, the actual cycle influence of various parameters on system performance. Okay, actual cycle influence of various parameters on system performance, and the use of pH charts and some of the problems related to the vapor compression refrigeration cycle. So this is a small unit so that we can complete by 6 to 8 classes, right? So be available and listen the session. So total how many participants? Durga. Okay, Durga, we'll start the class. So in the last classes, you got some basic idea of refrigeration system. So now we'll see the some of the types of refrigeration system where you are using at a domestic level, that is at our home. Now coming to the types of refrigeration, first one, vapor compression refrigeration system. Refrigeration systems lo vapor compression refrigeration. They use mechanical energy, that is VCR. Next one is vapor absorption refrigeration system, which uses thermal energy. So vapor compression refrigeration uses mechanical energy. Vapor absorption refrigeration uses thermal energy, right? So we are having the topic vapor compression refrigeration, which is in the syllabus. So we discuss about VCR. We discuss about V, C and R. Next. So generally you know the refrigerator meaning, right? So absorbing the heat from the cool body and ejecting to the hot temperature reservoir. The transfer of heat from the low temperature region, transfer of heat, moving the heat అంటే heat low temperature region నుంచి high temperature region కి పంపించడాన్ని we are calling them as refrigerators, right? Transfer of heat from low temperature region to the high temperature region requires special devices known as refrigerators or freezers. The objective of refrigerator is to remove the heat from the cold medium లో heat ని బయటకు తీసేయడం. The objective of the heat pump is to supply the heat to the warm medium. అంటే heat pump యొక్క లక్షణం ఏంటి? So the objective is to supply the heat to the warm medium. So warm temperature లో heat ని సప్లై చేయడం. రెఫ్రిజిరేటర్ వచ్చేసి heat ని ట్రాన్స్ఫర్ చేయడం, లో టెంపరేచర్ నుంచి హై టెంపరేచర్ కి ట్రాన్స్ఫర్ చేయడం, రైట్? See here. The quotient of performance of refrigerator is equal to desired output by required output. Desired output by desired output ఏంటి cooling effect కావాలి. What is the required output? Work input. Therefore, desired output Q by W. See here, the work input, we are giving the work input to the refrigerator. Here, the refrigerator is absorbing the heat QL from the low temperature reservoir and sending out to the high temperature reservoir. Sending to the high temperature reservoir. Next. So how does this VCR work? Right? The thermal energy moves from left to right through 5 loops of heat transfer. So heat transfer concept lo, the thermal energy is moving from left to right through 5 loops anamata. Left nunchi right ki, left to right, left to right, left to right. Now see here, indoor air loop, chilled water loop, refrigerant loop, condenser water loop, and cooling water loop. So these are the 5 types and matter. So here the supply chain fan, so what happens here in the supply chain fan? So in the supply chain fan, the air is passing into the cooling coil. The air is passing into the cooling coil, supply of air into the cooling coil. Later it is transforming to the chilled water pump. Later the cooling coil is transforming the chilled water into the pump through the evaporator. Now what does this evaporator is doing? This evaporator is sending the water to the condenser by compression refrigerant loop by using the refrigerant and that is a chemical substance which is used to cool the substances, now from the condenser the cool water is passed to the cooling water tower. Here the water cooled water condenser pump. Through the condenser pump the cooled water is passed to the cooling towers, and from the cooling tower the cooling water fan, through the cooling water fan the air is passing outside. So in this way the refrigerator works. So it is having 5 looping process. One is indoor air loop, chilled water loop, refrigerant loop, condenser water loop, cooling water loop. So like this we are having 5 processes where the thermal energy is moving from process 1 to process 5. Understood? So this, in this way the refrigeration process works. Next one, vapor compression refrigeration system. So this is the main topic what we are discussing and we are having in our syllabus of unit 2. So the vapor compression refrigeration has 4 components to discuss. One is evaporator, other one is a compressor, other one is a condenser, other one is a expansion valve. So what are the 4 main feature components you are having? The 4 main components are evaporator, compressor, condenser and expansion valve. Next point, this is the most widely used VCR cycle. The most widely used cycle. The most widely used cycle is VCR. In an ideal vapor compression refrigeration cycle, the refrigerant first enters into the compressor. Okay, refrigerant ఏం చేస్తుంది? Refrigerant enters into the compressor as the saturated vapor and is cooled to the saturated liquid state in the condenser. So ఇందాక మనం చూసిన 5 loops లో, so here the water is sending into the evaporator and into the condenser and it is passed to the cooling tower. So what it is saying here, in an ideal vapor compression cycle The refrigerant అనేది enters the compressor as a saturated vapor. So this refrigerator enters into the condenser. Refrigerator enters into the compressor as a saturated vapor and is cooled to the saturated liquid state in the condenser. Next, it is then throttled under expansion. It is then throttled to evaporator pressure and vaporizes as it absorbs the heat from the refrigerator space. Next, what it is doing? So from the compressor, from the compressor, it is then transferred to the throttled to the evaporator pressure and vaporizes. What happens? The water get vaporizes as it absorbs the heat from the refrigerator space. Finally, from the air moisture, we are getting cool breeze as a airflow. Got it? Now, the ideal vapor compression cycle consists of four processes. Right? Now, what are the four processes here? The first cycle is isentropic compression process. The process 1 to 2 is isentropic compression. 2 to 3, constant pressure heat rejection in the condenser. The second 2 to 3 cycle, the 2 to 3 phase is constant pressure heat rejection in the condenser. Constant pressure heat rejection in the condenser. What is 3 to 4? Throttling in an expansion valve. Throttling in an expansion valve. Right? Next, what is 4 to 1? Constant pressure heat addition in the evaporator. Fourth one is constant pressure heat evaporation in the evaporator. So these are the three types. These are the four types of processes. 1 to 2 is isentropic compression. 2 to 3 is constant pressure heat rejection. 3 to 4 is expansion, throttling in expansion. 4 to 1 is a constant pressure heat addition in the evaporator. So these are the four main things what we are dealing. Right? Next. If you see the pH diagram of an vapor compression refrigeration system, it will be in this form, right? See here, the 1 to 2. That is 1 to 2 is a isentropic compression. 2 to 3 is compression condenser heat rejection. Heat is going out from the condenser. Warm environment, heat is going out to the condenser. From 3 to 4, the throttling expansion valve. From 4 to 1, what happening? Here the QL. QL is nothing but cold refrigerated space. QL, cold refrigerated space, where the cool air is evaporated into the carbon. Right? So the cycle flows in this process. Now, in this process called refrigerator space and then the compressor. So if you see the TS diagram, so the 1 to 2, this one 1 to 2, the warm air is inside. 2 to 3, the heat is rejected. 3 to 4, expansion, throttling happens. 4 to 1, automatically saturated, right? So like this, you are having the temperature and entropy. Now coming to the pH, we are having 1 to 2 as a WN, 1 to 2 as WN, 1 to 2, 2 to 3 heat is rejected, 3 to 4 is expansion, 4 to 1 is heat, constant pressure, heat addition. So he is taking heat addition. QL is heat added, QH is heat rejected. So this is the pH and TS diagram of refrigeration system. Okay, na? The ordinary household refrigeration refrigerator is a good example of this cycle, the household refrigerator. So generally we are having general గా మన ఇంట్లో every house is having a refrigerator. So what type of refrigerator? What type of refrigeration system generally we are using? So we are using vapor compression refrigeration system, which is mechanically used, and also vapor absorption, that is thermally used, where these are used in large applications. So vapor compression అనేది domestic applications లో ఇంటిల్లిపాది we are using. So the ordinary household refrigerator is a good example of the application of this cycle. Okay, so if you see the actual vapor compression, so see here the work done in thereby the air it compressed and passes to the condenser. So whenever this is working is compressed in the compressor, the cold air refrigerator space through from the evaporator, it is passing into this place. So from here the heat is the warm air is rejected outside from the condenser, it is passing to the expansion throttling valve. It is being stabilized at 5 to 4 to 5 and 5 to 6, and from 6 to 7 it is passing to the evaporator, and 8 to 1 it is passing again to the cycle starts, right? So if you see the refrigerator, see here a back of a refrigerator, you are having a capillary tube, you are having this S-shaped jolly at the back of the face, and the heat is coming out. QH is a heat coming out, and this one is a condenser coils, and this one is a compressor, right? So here on the top also this capillary tube is circulated and passing into the compressor chamber. So E cycle, which is a compressor on the condenser, capillary tube, this total cycle is placed at the back of a refrigerator, and here you are having defridge component, and here you are having normal component. So మనకి ఫ్రిడ్జ్ లో ఎంత టెంపరేచర్ ఉంటుంది కింద క్యాబిన్ లో, దట్ ఈస్ నార్మల్ క్యాబిన్, we are having 3 degrees centigrade, and at the top you are having minus 18 degrees centigrade. So that's why if you keep the water bottle inside the deep freeze, so within 2 to 3 hours it will get ice solid form అయిపోతుంది. అదే మీరు 24 hours పెట్టిన 200 to 3 to 4 days, if you are keeping the water in the refrigerator, so it will not become ice, because you are having the temperature is 3 degrees centigrade, right? Only 3 degrees centigrade you are having. Next, hope you understood. Next, the VCR cycle, vapor compression refrigeration cycle, is a common method of transferring heat from a lower component to the higher component. So general గా ఈ స్టేట్మెంట్ మనకి తెలుసుకున్నాం. సో it is transferring the lower component to the higher component, higher temperature. Now if you see here, refrigerator ఏం చేస్తుంది, వర్క్ ఇన్పుట్ జరిగినప్పుడు refrigerator-లోకి కోల్డ్ రెఫ్రిజిరేటర్ స్పేస్ నుంచి హీట్ అనేది తీసుకొని ఇది దీనిలోంచి దీనికి పంపిస్తుంది, వార్మ్ ఎన్విరాన్మెంట్కి ఇట్ విల్ సెండ్ అవుట్ సైడ్. దట్ ఈస్ ద కాన్సెప్ట్ ఆఫ్ రెఫ్రిజిరేటర్. అదే హీట్ పంప్ ఏం చేస్తుంది, హీట్ పంప్కి మనం వర్క్ ఇన్పుట్ ఇచ్చినప్పుడు కోల్డ్ ఎన్విరాన్మెంట్లో నుంచి వర్క్ తీసుకొని వార్మ్ హౌస్కి అవుట్పుట్ అనేది పంపిస్తుంది. దట్ ఈస్ ద మీనింగ్ ఆఫ్ ద హాట్ heat pump. Got it? The above figure shows the objectives of a refrigerators and heat pump. The purpose of refrigerator is to remove the heat, called the cooling load. So మనం టెక్నికల్గా ఏం చెప్తున్నాం, the purpose of refrigerator is to removal of heat ని రిమూవ్ చేయడం, called the cooling load, and from the low pressure temperature to the high pressure medium. The purpose of heat pump is of a transfer. The purpose of heat pump is the transfer of heat. So in ఇక్కడ it is the purpose of the heat pump is the transfer of heat to the high temperature medium, called the heating load. దీన్ని మనము కూలింగ్ టెంపరేచర్ దాన్ని కూలింగ్ లోడ్ అంటున్నాం, హైయర్ టెంపరేచర్ దాన్ని హీటింగ్ లోడ్ అని చెప్తున్నాము, రైట్ ఇట్. Next, hope you understood. Next, so when we see some of the topics related to the VCR and normal thing, so we can see the interested in that heat energy removed from the low temperature, the device is known as refrigerator. So already it is confirmed. When we are interested in the heat energy removal from the low temperature, so మనకి ఫ్రిడ్జ్ బయట ఉన్నప్పుడు ఆటోమేటిక్గా మనకి వేడి టెంపరేచర్ మనకి తగులుతుంది. సో వై ద హీట్ is rejecting at that point, right? The heat is rejecting at the point. So whenever we are interested in the heat energy removed from the lower temperature, that device is known as refrigerator. When we are interested in the heat energy supplied, when we are interested in the heat energy removed, when we are interested in heat energy supplied, heat energy మనం పంపిస్తున్నాం అనుకో at the high temperatures కి, the thing is known as heat pump. In general, the term heat pump is used. In general, the term heat pump is used to describe as the heat is removed. As the heat is removed. So in general, the term heat pump is used to describe the cycle as heat energy is removed from the lower temperature space and rejected to the high temperature space. High temperature space. So these are the few points related to the vapor compression, refrigeration. Now, if you see the performance of the performance of refrigerator and the heat pumps expressed in terms of coefficient of performance, it is defined as, if you see here, the COP of refrigerator. The COP of refrigerator is equal to desired output by required input. The COP of our refrigerator is desired output by required input, and a cooling effect by working input, that is equals to QL by W net. W work input in. Coming to the second one, the COP of heat pump is equal to desired output by required input, that is heating effect divided by work input, that is equal to QH divided by work input. Now both the COP of R and COP of heat engine can be larger than 1 under the same operating conditions. So the COP is related to COP of heat pump is equals to COP of refrigerator plus 1. Absolutely, COP is equals to COP refrigerator plus 1. So this is a coefficient of performance of heat pump and refrigerator. Got it? Right? Next, if we'll see the thermodynamics of ideal VCR cycle. So if you see the thermodynamics of VCR cycle, ideal vapor compression refrigeration cycle has we are having 4 processes, right? What is the process? 1 to 2 adiabatic compression process. The work input jarugutunnappudu the heat we are giving in to the compressor, that is adiabatic compression process. And 2 to 3 constant pressure heat rejection in the condenser. Constant pressure heat rejection in the condenser. Third one is 3 to 4 throttling in an expansion valve, changes happening in the expansion valve. Next, 4 to 1 4.1 is constant pressure heat addition in the evaporator. Okay, constant pressure heat addition in the evaporator. So these are the thermodynamics of ideal vapor compression refrigeration cycle. Understood? The 1 to 2 is adiabatic compression process. మనం ఫ్లో చార్ట్ మనం ఫిగర్లో చూసినప్పుడు 1 to 2 is adiabatic compression process, 2 to 3 is constant pressure heat rejection in the condenser. Constant pressure heat rejection in the condenser. 3 to 4 is throttling in an expansion valve. Throttling in an expansion valve. 4 to 1 is constant pressure heat addition in the evaporator. Constant pressure heat addition in the evaporator. So these are the four processes where we are using thermodynamic concepts of ideal VCR cycle. So we discuss each of one of this in detail. See the refrigerator. So here the refrigerator is opened. Now if you see the refrigerator, here you are having the suction tube. Here you are having the evaporator. Here you are having the temperature control. Here you are having the capillary tube. Here you are having the condenser. Here you are having the compressor. So compressor ikkadi nunchi, right? So the compressor. So it is going to the condenser. It is going to the capillary tube, and from here the temperature controls, it is passing to the this tube, and it is passing onto the compressor, and it is going into the condenser mode, and again to the capillary tube to the outside, right? Next. So see here, the cold refrigerated space evaporator is taking the heat, and the condenser is extracted outside, that is warm environment. Warm environment. Got it? Here 1 to 2 compression, 2 to 3 is a process, 3 to 4 is a throttling, 4 to 1 is a process. Got it? So here we are having four components. One is compressor, condenser, expansion valve, and evaporator. To see the pH diagram as shown in the earlier slides, we are having 1 to 2, 2 to 3 heat rejection, 3 to 4, and 4 to 1 heat addition. 4 to 1 is the heat addition. Next. So if you see in a simple example of this VCR cycle, take a technical details, that is example of Samsung split AC. Okay, so window box A, B రెండు బాక్స్లు ఉంటాయి split AC. So లోపల ఒకటి బయట ఒకటి పెట్టుకుంటాం. So if you see the example of a split AC, the model cooling capacity is 7.03 kilowatts. Power consumption 2600 watts. So if you see the refrigerators nowadays, on the top of this refrigerator you can see the energy savings guide. And this is simply energy consumption, that is 2600 watts. And a refrigerant type. Coming to the refrigerant type, what is the type of refrigerant you are using? We are using type 22 refrigerant. So refrigerant ante enti, what are the types and where we are using what for అనేది మనకి నెక్స్ట్ యూనిట్ 3 లో మనము డిస్కస్ చేసుకుందాం, రైట్? సో now we'll see only the basics of what you are having in a refrigerator. Next, fourth one is the refrigerant leaves the evaporator at 7.2 degrees centigrade. Next, the condenser pressure. The condenser pressure is 2.71 megapascal. So the condenser pressure where we are using is 2.7 megapascal. Got it? So these are the technical details of a Samsung company split AC model number AQ24UUA. Got it? Now the next topic to be discussed is the components of vapor compression system, right? We'll discuss the components of vapor compression system, VCR. So if you see the compressor, the low pressure and temperature refrigerant from the evaporator is drawn into the compressor. అంటే evaporator లో నుంచి, right, from the evaporator the refrigerant, low pressure low temperature refrigerant is drawn into the compressor, దానిలోకి వెళ్తుంది. సో evaporator లో నుంచి refrigerant compressor లోకి వెళ్ళి through the inlet or a suction valve. So what type of channel we are using? Through the inlet or suction valve where it is compressed, ఎక్కడైతే కంప్రెస్ అవుతుందో at a high pressure temperature. సో సింపుల్ గా కంప్రెసర్ ఏం చేస్తుంది? ఇట్ కంప్రెసెస్ the refrigerant which is having low temperature, low pressure to a high pressure, high temperature refrigerant. అర్థమైంది కదా? నెక్స్ట్ పాయింట్, then the high pressure, high temperature refrigerant is discharged into the condenser. సో ఇక్కడ ఏం జరుగుతుంది? సో the refrigerant is passing from the compressor to the evaporator, from the evaporator into the condenser through the delivery for discharge valve, through the delivery or a discharge valve. So that is the main activity done by the compressor. So what it is doing? So here the compressor is taking the low pressure and temperature refrigerant evaporator లో నుంచి low pressure temperature తీసుకొని, right, the compressor takes low pressure temperature refrigerant from the evaporator and it passes to the compressor to the high pressure temperature. The high pressure temperature refrigerant is discharged into the condenser through the delivery tube. So that is the main thing happening in the compressor mode. Next one, condenser process. Condenser is a unit or a cooler. Condenser entity, it is a cooler which is in the form of pipe at the backside of a fridge. A condenser or a cooler has coils of pipe in which the high pressure temperature vapor refrigerant is cooled and condensed. సో మీరు ఫ్రిడ్జ్ వెనకాల చూసారంటే ఒక జాలి ఉంటుంది, ఒక మెష్. ఆ మెష్కి యు ఆర్ హ్యావింగ్ సమ్ bended tubes. It may be made of copper. The condenser or a cooler consists of coils in which the high pressure temperature vapor refrigerant is cooled and condensed. So that is a concept of condenser. The refrigerant while passing through the condenser, so whenever the refrigerator is passing from compressor to the evaporator to the condenser, it rejects its latent heat to surrounding condensing medium. And that's why if you see the backside of refrigerator touch the condensing coil, it will be in heat hot condition. Why? So here the refrigerant is passing through the condenser, rejects its latent heat to the surrounding condensing medium, which is normally air or water. So water మనకి కింద కనిపిస్తుంది, కింద ట్రేలో పడిపోతుంటుంది, రైట్? సో this passes that medium, air or water medium, inside the bottom bucket of the refrigerator. Next, receiver. The condensed liquid refrigerant from the condenser is stored in a vessel known as receiver. So whatever the refrigerant which is ready, which is condensed in the condenser, is stored in a vessel. So the refrigerant is stored in a vessel known as receiver vessel, where it is supplied to the expansion valve or refrigerator control valve. So next ఏం చేస్తుంది? 3 to 4, that is throttling expansion valve. Here the refrigerant which is stored in the receiver is supplied to the expansion valve or a refrigerator control valve. Next, expansion valve. So what happened to the expansion valve here? The function of this valve, the expansion valve, the function of this valve is to allow the liquid So what is this valve do? What does the expansion valve or a control valve? It allows the liquid refrigerant. ఏం చేస్తుంది? It allows the liquid refrigerant under a high pressure temperature to pass at a controlled rate after reducing its pressure temperature. So what does this expansion valve will do? Because it has a relays and automation concept, the expansion valve will takes the refrigerant at high pressure temperature and passes at controlled rate after reducing its pressure and temperature, and some of the refrigerant evaporates as it passes through the expansion valve, but the greater portion is vaporized in the evaporator at low pressure temperature. So ఇక్కడ ఏం జరుగుతుంది? expansion valve it takes the refrigerant under high capacity, under high temperature, and passes to the controlled rate after reducing the temperature. Some of the refrigerant evaporate as it passes through the expansion valve, but majority it is vaporized in the evaporator. Where majority is vaporized in the evaporator. That is the concept of vapor compression refrigeration cycle. Next, what does evaporator do here? The evaporator consists of a coil of pipes. That an evaporator consists of coils of pipes in which the liquid vapor refrigerant at low pressure temperature evaporated and changed into vapor refrigerant at low pressure. So evaporator ఏం జరుగుతుంది? The refrigerant which is in a liquid state is converted into gaseous form. During the evaporation process, the liquid vapor refrigerant absorbs its latent heat and heat of vaporization from the medium which is to be cooled. So this is the, I think you are getting bored, right? So vapor medium which is to be cooled. So the evaporator ఏం చేస్తుంది? The evaporator takes the hot temperature pressure refrigerant and converts into cool temperature, that is low temperature pressure refrigerant. At this process, the liquid refrigerant absorbs its latent heat from the medium which is to be cooled. So that is a concept happening with the air evaporator. That is happening with the evaporator, right? Next. So what is the time? 2:37. Next. So if you see the schematic diagram of vapor compression refrigeration cycle, so we are having four main components: a compressor, a condenser, the expansion, evaporator. Right? So see the simple line diagram. So we'll discuss in detail the how this cycle, how this chart works. Right? So when you get a question, just draw the simple diagram, line diagram. So the expansion valve, first draw the box evaporator, next సగం తీసుకొని diagram, draw the evaporator first, later draw the compressor where you are getting compressed. So it should be 5 to at some place at the height of the evaporator, right? You are having a compressor, lower pressure side and upper pressure side. Throttle compressor process. From the compressor, the blue color indicates the cooled air is passed into the condenser. From the condenser, it is going into the expansion valve, and from the expansion valve, it is passing again to the evaporator. So this process takes a cyclic form: 1 to 2, 2 to 3, 3 to 4, and 4 to 1. So cycle bottom side you are having low pressure side, cycle top side you are having high pressure side. Got it? So with this we'll stop the class. We'll discuss the class in the tomorrow session. As I have the class at 3 p.m. for diploma students, we'll stop the class here. We'll continue in the tomorrow's class. So only Durga Prasad were present in the session. So I'm taking the attendance and posting it. So thanks for listening to the class.